Hi, so today I will be talking about something I saw recently. So, this is my tab which has a LCD screen. So, I was studying in my tab and sunlight was coming from this window. And then I saw that the direct sunlight, when it hit the screen of my LCD tablet, it made pattern, and I didn't know why the pattern was being made. But then I did something on the internet and found out something which I'm going to tell you. So let's first see what the phenomenon is like in real life. Here I will be using this flashlight of my mobile phone, and shine it upon the tab. So you can see the pattern of X is being made, and which is also giving off a pattern of rainbow or spectrum. Center point of the spectrum is white, and it is giving off something like rainbow. And if I rotate my tab, see, it rotates with the tab. It is now horizontal, it is now vertical, it is now horizontal. So I was curious about why this was happening. Then I thought that, well, this can be due to diffraction grating. What is diffraction grating? So at first it was discovered in feathers of birds. You know, some bird feathers like peacock feathers, they are shiny, they give off some rainbow colored diffraction when seen in sunlight, like peacock feathers. But if I scrape off the peacock feather, I cannot find the pigment that is making that color. So why is the color like that? Similarly, some butterflies, they also have blue colored wings, but if I scrape off the wing of the butterfly, I cannot find a blue pigment mostly. Why? Where is that color coming from? So the color is coming due to diffraction grating. What happens is that tiny slits, if there is in a surface and light is coming through them, then there is interference happening, and due to that the color is divided along with their respective wavelength. Will be a primary diffraction grating, and there will be a secondary, so on and so forth. There may be two kinds of diffraction grating, like if I have a grating plate here and light source from here, so I will see the grating from this side, or there is the grating plate and I light from this side the surface, and the grating will hit my eye in an angle. So why would of everything this LCD panel give me the diffraction grating? Is it does it has any small slits? Well, yes, because this is made of pixels. This screen is made up of pixels. So there are small semiconductor light emitting diodes planted in the screen, and because of their arrangement, they have many slits in two-dimensional space. There will be a gap in the x-axis, and there will be a gap in the y-axis. So in both axes there will be some pattern of multiple slits, and due to those two axis patterns, there we can see a diffraction grating of two-dimensional cross. One is for the x-axis component and other is for the y-axis component. And again, there can be a confusion that the colors we can see in this diffraction grating are due to RGB component of the LED lights, but the screen is off. And the thing is, this light which I have shown in this thing is not monochromatic, it is mixed light. It has all the wavelengths. So because of that, the in the diffraction grating I am seeing a spectrum forming. If I had used only red colored light, which sadly I don't have, then you could have seen that only red colored X is forming and it is dotted. So there will be a red colored dot and there will be a red colored band, there will be a red colored band. So this X would not be a continuous like that. So I thought I had noticed something like that in my college life, which I didn't think about much. So now when I think about it, it was something like that only. What was that? So one day in college, I was trying to click some pictures with my mobile phone, and there was a light source like the street lamp on our college, and the light was making a weird halo around it, a straight line, which I have never seen before. My camera, I thought my mobile camera has broken or something. I swiped it with my clothes, and then the pattern changed. Let me show you what I am trying to say. Suppose this is the camera. I've opened my camera and this is the light source. Now, as you can see, there is a line, straight line along the x-axis of this tablet. Now I will take my finger and I will gently scratch along this surface in x-axis. Let's see what happens. See, the beam of light has now become vertical. Actually it is the 90 degree, perfectly 90 degree to the direction of scraping I have done with my finger, and it will stay same with the direction of the screen. It is 90 degree only. So intuitively, if I want to, let's say, make a pattern that the light will make a pattern like this, so I have to scrape the camera with my finger in this direction, perpendicular to it. Let's do that. I am doing that, and see, it has been like that. So this is also a kind of diffraction grating. And why is this happening? This is happening due to the smudge, which we call smudge. Like our fingers have sweats, have various kind of oils, dirt particles in it, and when we scrape a surface like the camera lens, glass surface, with our finger, the tiny multiple coops or slits are being made in that direction, and due to the diffraction grating we are getting this line. So I have another example for you. Let's open this tablet, and now I will scrape the screen of the tablet with my elbow, and I will swipe it in this direction. Okay, now I have swiped the screen in this direction. So if I shine light in this, the pattern should be in this direction. Let's see. Is it happening? So you can see that the X that is making, that is spectral, but the straight line which is happening due to the scraping or multiple slits on the surface of the tap is monochrome, like white only. Why is that? It is due to the difference of the size, because the pixels are much larger in size than the scrapings produced by small particles in my hand. So the difference of diffraction angle of different wavelengths is different, though the power of dispersion, the dispersion power of that diffraction system is low. There are some more real life examples of this phenomenon also, like our own eye. We have lenses and cornea in our eye that are mostly transparent, but they do have some opaque fibers, or they can develop due to cataract or some opacities. So if we squint our eyes and look towards a bright source of light, we can see that radial spokes of light rays are coming out from that light source. And then if we tilt our head in either direction, we can see that the spokes of lights will also move with our head. So this is also example of this diffraction grating. Well, that's it. Hope you find it intriguing, but I am not a student of physics. I don't know much about this. If there has been any mistakes, please correct me. Goodbye.